Okay, using the substitution u is square root of x minus 1, find the value of a crazy integral. Okay, that's fun. Let me just do one thing. Okay, so I just cropped this and I'm going to put it here next to me so you can see it, and I'm going to be solving this up there. Okay, so substitution, we are given a hint that we should be using u equals square root of x minus 1, and the integral I'll have to calculate is right there, but let me just rewrite it here just for myself. From 1 to 4, 2, and I'm going to plug in this u, right? No, I'm not going to do that. I'm going to first write the entire thing the way it is there, and only then I will start plugging in this u. Now, before we plug in the u, let's figure out what is the differential when we substitute. Well, clearly there is u in this square root, and there's going to be u plus 1 in the denominator, but the most important thing is to figure out du. Now, du by dx is the derivative of this function with respect to x, and that function is can be easily rewritten as x to the power half. There is another video of mine where I explain why this is the case, why square root of x is the same thing as x to the power half, but I'm not going to do this in this video. Minus 1. Now, when we take this derivative, minus 1 disappears simply because it becomes 0, and the rest is half times x to the power half minus 1. This is the standard derivation formula, and half minus 1 is minus half, so half times x to the power minus half. Minus makes the thing go around, so we have basically square root of x in the denominator. So this is the derivative of square root. Looks like this, and this means that the differential u. Sorry guys, didn't mean to do this. Just gonna move this. Yes, yeah, still here. Differential is equal to this. I mean, that's one way to put it. Another way to put it is that the another way to put it is that this 1 divided by 2 square of x is the derivative of the internal function in this integral. Anyway, let's see what happens. Because now actually, yeah, it's going to be easy to bring this into this form. How are we going to do that? Let's take these 2 out from the integral, and in fact let's take another 2 out of the integral, so we basically put 4 times, and to compensate we put 2 in the denominator, so we get this expression. And now we can see that this together with this is the differential. So basically now it's easy to substitute 4 times, and then we have square root of u. I don't even need to do this. I mean, it's just going to be this times du. So this is the thing I have to calculate, and afterwards I'll just put back whatever u is. So, oh, sorry, I have to remember to do the right bounds. So if x was going, so let's calculate the bounds. So if x was going from 1 to 4, then square root of x is going to be between square root of 1 and square root of 4, which is of course 1 and 2. And square root is a monotonously increasing function, which is why taking square root in this inequality on each part will not change the signs of the inequality. And then subtracting 1 will make this 0 is less than square root of x minus 1 is less than 1, which means that the u goes from 0 to 1. So the new bounds are from 0 to 1. I almost made a mistake by forgetting to do that. Okay, almost is almost. It means that there was no mistake. Let's continue. Now we should take the integral of a square root. We just previously calculated the derivative of the square root, but the integral of the square root, integral function of the square root can be computed in the same way, basically the same idea. We put power half, and then they do the opposite, so the power increases by 1, and then we also put this power increased by 1 into the denominator. So that's the integral function. I'm sorry, this integral sign here is not necessary. This is the integral function. Now if I simplify it, is going to be u to power 3 halves divided by 3 halves, which is equal to 2/3 square root of u to power 3. So this is what I'm going to be using. So now when I need to calculate the full thing, I will use this expression. So there's going to be 4 times 2/3 square root of u to power 3, and then we have u going from 0 to 1. Right, okay, so we actually don't need to go back to substituting this original thing in place of u anymore. I didn't realize that when I said that before, but we don't have to do this. So we just substitute 1 and 0 in there. So 4 times, and we realize immediately that when we are going to put in 0, it will be just 0, so we don't have to care about the other bound because it's just 0. And so we only put in 1 in there, and that's going to be the answer. And when we put 1 in there, and this entire thing is going to be 1, so this is just this, okay, times 1, if you will. And that is, what is this? 4 times 2 divided by 3, that's 8/3, and this has to be brought into a form which is an integer and a fraction. So this is 2 and 2/3. That's the answer. And